So, okay, O levels chemistry demo class, and I'm going to conduct this class on making equations. Okay, that's one of the most important things that you're going to do in chemistry. That's one of the most important things. Okay, making equations on stoichiometry, balancing equations. That is very, very important, or that is the fundamental thing of chemistry. Okay, if you don't know how to make equations, you would pretty much not be able to do uh, make equations and formulas. If you don't understand it, you won't be able to do pretty much most of the major topics that are in chemistry. Okay? For example, acid, bases, and salts, metals, हर जगह equations होती हैं. ठीक है? Organic chemistry is full of equations. Similarly, electrolysis, formulas, etc. They would come over and over again. So these are one of the most basic things. So we're going to start very quickly. It's going to be a rough revision or a quick recap of the topics that you've studied. One is we're going to start with the very basic things, and that is before going towards equations, I'm going to talk about formulas. Okay, how do you? And I'm going to specifically talk about ionic compounds, but very, very quickly. Uh, Okay, if you look at the periodic table, and if you imagine that this is your periodic table, the periodic table, there's one side which is your side, which is the left hand side. They're called metals over there. Okay. On the other side, you have your non-metals. As a beach, so gradually when you move in the periodic table from the left side to the right side, what happens to the elements is that they change from metallic character to non-metallic character. Uh, the first question is, why are the left side elements called metals and why are the right side elements called non-metals? That's the first question. Okay, what makes a metal and what makes a non-metal a non-metal? Now, one of the most fundamental things about metals is, okay, when they bond, they lose electrons. They lose electrons and they try to form positive ions whenever they react with other elements. Okay, so they form positive ions. So they like to form positive ions. They like to lose electrons. On the extreme right side, you have your non-metals. When they react, what they do is they try to gain electrons. Okay, they try to gain electrons, and when they gain electrons, they form negative ions. Okay, that's one of the most basic things. Okay, what's a metal? What's a non-metal? So that's a very loose definition. Okay, metals they form positive ions, non-metals they form negative ions. But next question, okay, why is it that elements on the left side they always lose electrons, and why is it that the elements on the right side they always gain electrons? Okay, why is that happening? The reason that is happening is, if you look at the periodic table is arranged in a way. Okay, for example, if I look at period number 2, okay, so period number 3 actually. So there's Na and Mg, and then there is Al, and then carbon and not carbon, silicon, phosphorus, sulfur, chlorine, and argon. Achha, so you have your elements arranged in period 3 like this. Well, if there's a first row, then the second row, then the third row. Now, why are the left side elements called metals? Aluminium takna, they're approximately metals. Beach mein, remember, they are metalloids. Okay? Beach mein, there's a transition, you have metals, and then you move to the right, you have your non-metals. So there's a transition that's taking place. So why are they called metals? Why is sodium a metal and why is chlorine a non-metal? Why does sodium like to lose electrons to form positive ions? Why does chlorine, on the other hand, like to gain electrons? Now, what happens is कि आप खुद periodic table open कर लो. If you try to open the periodic table, you would notice that the elements are arranged according to proton numbers. ठीक है? Aluminium है, फिर silicon is 14, 15, then 16, and then 17, and then these noble gases 18. So what happens as you move to the right side of the periodic table? Why does the character of the element change? So as you move to the right side, one thing that happens to the elements is, okay, and in any row, okay, pick any row, this is going to happen. Okay, the left side elements have fewer protons. So right side वाले elements they have more protons. So for example, if you have sodium and you have chlorine, so I'm going to draw sodium and I'm going to draw chlorine. ठीक है, one of them is a left side element, the other one is a right side element. And I'm going to quickly draw sodium. Sodium has a total of 11 protons. ठीक है, so let's say there's this nucleus and 11 protons. Chlorine has a total of 17 protons. ठीक है, let me circle this over there as well. So अभी पहला जो question we're trying to answer is why are metals losing electrons, why are non-metals gaining electrons? So you have 11 protons and you have 17 protons. अच्छा, 11 electrons. 11 electrons में कि you have 3 shells. ठीक है, hopefully this is clear कि 288 करके electronic configuration होती है. We're not doing that right now. अभी बिल्कुल basics कर रहे हैं. इसका भी this one also has a total of 3 shells. And then there's a third shell. So ठीक है, I've drawn the 2 atoms. Now I have these 2 atoms. One is sodium, the other one is chlorine. And this one over here is chlorine. Now the first thing is, okay, why are electrons attracted to an atom? Reason is कि जो center में nucleus होता है ना, this nucleus over here is positively charged. ठीक है, it has a very strong positive charge. Now, if you look at chlorine over here, chlorine has a much stronger positive charge, 17 protons. ठीक है, ये हमने discuss किया था कि when you move to the right side of the periodic table, the number of protons increase. If the number of protons increase, इसके पास कम proton है. This one has lesser protons. This other chlorine has more protons. So which one is going to have a stronger attraction for electrons? Because chlorine has more protons, ठीक है, it's on the right side, it's a non-metals. Non-metals usually will have more protons. ठीक है, so since chlorine has more protons, there's going to be more attraction for electrons. ठीक है, तो simple reason ये है कि why do non-metals, they are always gaining electrons? The reason is कि pick any non-metal on the right side of the periodic table. So in the row, it is the element which has more protons. ठीक है, 17 protons. Sodium के पास जो metal है, it only has 11 protons, which means it's not really attracting its electrons very strongly. तो ये भी लिख लेते हैं इसके नीचे कि over here there is going to be there are lesser protons. So there's going to be less attraction for electrons. Even जो उसके अपने electrons है ना, the ones that it already has, there's going to be very less attraction for electrons. ठीक है, so the attraction for electrons is not going to be very strong. So let's bring in the electrons first. So sodium has 11 electrons. Remember, sodium is not attracting those 11 electrons very strongly. Why is it attracting the 11 electrons very strongly? Because 11 protons जो है उसके ऊपर इतना positive charge, the positive charge is not very strong. So there's not enough attraction for these 11 electrons. So these are loosely sticking to this nucleus. Chlorine, on the other hand, has 17 protons. एक तो वो naturally it's attracting more electrons. ठीक है, so 17. So it's going to be 2, 8, and 7. ठीक है, so there's going to be 2, 8, and 7. And now more protons would lead to more attraction for electrons. Now what chlorine would do is if chlorine comes close to a non-metal, it's going to steal that electron from the non-metal and bring it to itself. ठीक है, so वो जो outer electrons थे ना, because sodium wasn't really attracting its electrons very strongly, So the outer electron of sodium would be lost to chlorine, and chlorine would steal it because chlorine has 17 protons, and since it has more protons, there's going to be more attraction for electrons, which is why chlorine would start pulling electrons from other atoms. I said, now these electrons, chlorine would not be stealing these electrons. Why? Because they're much closer to the nucleus. That one electron was very, very far away. So it was very far away, and which is why it wasn't really strongly held to sodium. So that electron is lost to chlorine, but not the other ones. It's very rare that the other electrons are lost because they are much closer to the nucleus, so the nucleus is holding them tightly. And as a result, this atom over here gets a -1 charge, and this other atom over here gets a +1 charge. और एक simpler version इसकी है कि atoms they like to complete their outer shells. ठीक है? So they now have complete octets and they're completely stable now. ठीक है? Although remember कि atoms don't really know कि what is a complete octet. ठीक है? I mean, atoms can't think. So the reason this is happening is this is a non-metal and it has more protons. It likes to attract electrons. तो वो उसके electrons को attract करके tries to fill its shells. If they're empty spaces. Now chlorine cannot attract more electrons. Why? Because all the spaces around it are now full. वो अगर attract करेगा तो रखेगा कहाँ पे? ठीक है? There's no empty place around it. And similarly, sodium would not lose more than one electron because it has lost the outer electron, but not the inner electrons. It's holding them tightly. So this is why, by default, atoms generally get a complete octet. For metals, it's always by losing electrons. For non-metals, it's always by gaining electrons. So metals, they form positive ions. Non-metals, they form negative ions. And the two ions, they end up attracting each other. Okay? So there's a force of attraction. And this force of attraction is known as an ionic. It's known as an ionic bond. And in an actual ionic substance, it's not going to be just one sodium and one Cl. It's going to be lots of sodium and lots of Cl ions. Sodium +1, Cl -1, and they would all be attracting each other. So they would be forming crystal lattices. Okay, if you have a sodium +1, it would be attracting a Cl -1. But that Cl -1 would in return be attracting another sodium +1. And that sodium +1 would be attracting another Cl -1. Or wo jo positive or negative ions, they would all be attracting each other and they would endlessly be attracting each other. They would form a three-dimensional lattice arrangement. So there's going to be a three-dimensional lattice arrangement. And eventually they would all be attracting each other. Okay? So there would be billions of sodium ions, billions of Cl ions, and all of them opposite charges always attract, so they would attract as well. So it's going to be a giant crystalline ionic lattice. So it's going to be a giant crystalline ionic lattice. Okay, the main point is, okay, hopefully this would be clear that metals, they tend to lose electrons. They always lose electrons very, very easily. Non-metals, on the other hand, they tend to gain electrons. उसकी reason क्या थी कि more protons, whereas these have lesser protons. ठीक है? So, Zad, Naeem, is this clear? So we can move on. I said then. ठीक है. I said then we have the next thing. ठीक है? Just a bit more on this. I said just a bit more on this. We can do another diagram, another dot and cross diagram, and this one would be related to another ionic compound. And let's talk about magnesium, which is another metal, and oxygen. Okay, so let's talk about this. So what type of, one is a metal, the other one is a non-metal. The same thing would pretty much happen once more. And in this case, let's draw magnesium first. Magnesium is a metal, it has 12 protons. Oxygen, on the other hand, has 8 protons. Okay. But apart from oxygen, let's take, instead of oxygen, let's take sulfur. Okay, 16 protons, same row. Now magnesium has 12 protons, so let's quickly draw 3 shells. And the other one has a total of 16 electrons, so that's also 16 protons in the middle. And so this one has 16 protons. And let's draw the number of electrons. So this would be 2 and 8. And 2 electrons in the outermost shell. Remember, K metal. Okay, this is Mg metal. So it has fewer protons. So there's going to be less attraction for electrons. Especially these outermost electrons. It would really not be attracting these outermost electrons. Inner electron, they would be much closer to the nucleus. So they are going to be attracted very strongly. So they're close enough. So the positive charge would be attracting the inner electrons, but these electrons are very far away. So it's not really going to be attracting these electrons very quickly, very strongly. So the chances that these 2 electrons in the outermost shell that are very far away, they're going to be lost. On the other hand, you have this other element, which is a non-metal, and the non-metal is, in this case, it's a chlorine non-metal, not chlorine, sulfur. So it's a sulfur non-metal, and it has more attraction for electrons. I haven't even drawn the electrons. Let me draw the electrons. There would be 2 electrons in the first shell, 8 in the second one, and 6 in the last one. So it has more attraction for electrons, but not only attraction for electrons, it also has room for electrons. It has exactly room for 2 electrons. But its outer shell must have 8 electrons, so it has room for 2 electrons. What it would do is, okay, the 2 electrons that were not being strongly held by magnesium, they are going to be lost, and those electrons would go to sulfur. And as a result, sulfur gets a -2 charge. Magnesium, on the other hand, gets a +2 charge. So this is an ionic compound, which is magnesium sulfide. Now this lattice would be a lot stronger because charges are greater. Mg2 plus would be attracting sulfur 2 minus a lot more strongly. Similarly, S2 minus would be attracting Mg2 plus a lot more strongly compared to. Now compare this lattice with the ionic lattice that we discussed earlier of sodium and chlorine. This wasn't a very strong lattice because +1 and -1 के बीच में the attraction is not going to be very strong. So it's not a very, very strong attraction, but when it comes to magnesium and sulfur, the attraction would be relatively much stronger because you have greater charge. So when it comes to ionic compounds, the thing is that stronger ionic lattices are formed based on 2 things. Number one is the charge on the ion. So if the ions have greater charges, then obviously the attraction would be stronger. So there's going to be a lot more stronger attraction if the ionic lattice is strong. Number two, second point, that is smaller ions. If the ion is small, remember size also is a factor. That if you look at this lattice over here, I mean all the ions are attracted to each other in a three-dimensional way. Lots of Mg and lots of S sulfide ions would be attracted to each other. So they would be forming a cubic lattice and all these ions are attracted. Now size also matters. Smaller ions, they're closer together. And if they're closer together, what that basically means is there's going to be more attraction. ठीक है, like magnets. ठीक है, दो magnets को बिल्कुल करीब करीब रख दो, so they're going to be attracted to each other much strongly. ठीक है, लेकिन अगर उनको दूर दूर रख दो, so they won't be attracted as strongly. So ions का भी ये होता है कि positive attracts negative ions. But if the ions are really close together, they're very tiny and they're close together, really tightly packed, then they would have a lot stronger attraction, which is why smaller ions, they're going to be closer together, so there's going to be more attraction. So ionic lattices, the strength of ionic lattices, how strong they are, how high their melting and boiling points are, how strong are they structurally, but a solid wise, that depends a lot on these two factors. So we did two compounds right now. One is sodium and chlorine. The other one is magnesium and sulfur. They're both ionic compounds. हमने ये पढ़ा कि metals they always tend to lose electrons, non-metals they always tend to gain electrons. And we also studied a lot depends on the strength of the ionic lattice. The greater the charge on ion, the stronger would be the attraction. A real world के अंदर ना there are lots of ionic compounds. Some are weak, some are strong. So let's discuss slightly about real world ionic compounds. Where do you see these ionic compounds? Okay, some of them are very easy to find. One is NaCl. So NaCl is one. That's your normal table salt. So this is a very weak ionic compound. Why is it a weak ionic compound? You can crush it easily. So it's a weak ionic lattice. वो हमने discuss भी किया था कि Na और Cl के ऊपर the charges are +1 and -1. So the attraction is not very strong, which is why your normal table salt, this could be easily crushed. So real world ionic compound NaCl table, normal table salt, that's a weak ionic lattice. Then there are others which are very strong ionic lattice. For example, there's a thing called calcium carbonate. ठीक है, उसमें there are two ions. One is calcium and the other one is carbonate. ठीक है, we're going to discuss these ions a little later on. Calcium or carbonate में कि this is called limestone. It's also known as marble. Chalk is the same thing. Plus cement, a major component of cement is also limestone. Now, this is a very, I mean, you know about marble, okay? So if you know about marble, marble is very strong compared to table salt. Why is it strong? Because the charges are greater. +2 or -2 के बीच में the attraction is a lot stronger, which is why जो marble का ionic lattice होगा, that would be it's going to be very strong. So limestone, marble, chalk, cement, okay? So this is a very strong lattice. And it's a very strong lattice. Why? Mainly because of greater charges. Because of greater ionic charges. So is this clear? Naeem, is this clear? Zad, is this clear? अच्छा, फिर एक next चीज हम जल्दी से कर लेते हैं, which is okay, right now what we did was with ionic compounds. Let's focus on ionic compounds a bit more. One thing that we did was over here, this was losing 2 electrons and this was gaining 2 electrons. Now we're going to come up with examples where the number of electrons lost and gained are going to be different. ठीक है, so we're going to do a few more examples. So now अब हमें ये clear हो गया कि the metal has to lose electrons, the non-metal is basically supposed to gain electrons. So now the issue is, what happens if the number of electrons gained and lost are not equal? One example is, let's talk about aluminium and oxygen. Now, aluminium is supposed to lose electrons, oxygen is supposed to gain electrons. Now, remember, in the real world, there's not just going to be one aluminium and one oxygen. There would be multiple aluminium atoms and multiple oxygen atoms. So let's start with aluminium. Aluminium has 13 protons. So that means, so it has 13 protons, and there would be electrons that would be around it. Okay, and a total of 3 shells. So there are 3 shells of electrons that are around aluminium. And the other one is oxygen. So oxygen has a total of 8 electrons and 6 in the outermost shell. Okay, so there are 8 protons. But oxygen is a smaller atom. So now over here, what would happen is the metal would lose electrons, and the non-metal is supposed to gain electrons. Now, if you look carefully at these two elements, you would notice that aluminium has 3 electrons that it has very little control of. They're very far away. So these 3 electrons are probably going to be lost. And when aluminium loses those 3 electrons, the end result is, so these 3 electrons are lost, which were in the outermost shell. The end result is that aluminium gets a charge of 3 positive, okay, because it has lost 3 electrons. So it gets a +3 charge. But if you look at oxygen over here, aluminium lost 3 electrons because the 3 electrons were very far away, and aluminium nucleus wasn't strong enough to attract 3 electrons. So it wasn't able to attract the 3 electrons, and those 3 electrons are lost. Now, oxygen would be the one that would be, it's a non-metal, it would try to gain those electrons. But oxygen, if you look at the shell, it only has room for 2 electrons. So 2 of the electrons would be gained by oxygen. So फिर इस एक का क्या होगा, which is just roaming around. So let's assume that oxygen has the capacity to gain just 2 electrons. Now there's a problem, and that problem is, where does this 1 electron go? Okay, aluminium likes to lose 3 electrons because they're very far away. कोई ना कोई उससे आके ले लेगा. Oxygen, on the other hand, has the capacity to just attract 2 electrons. So ये इसको नीचे भी लिख लेते हैं कि this lost, let me add the number, loses 3 electrons, gains only, gains only 2 electrons. So now you have an issue, which is, what do you do with this 1 electron? Okay, what happens to this 1 electron? Now what you do is, there's a thing called crisscross, which is, if this has a charge of 2 minus, okay, the crisscross method is, okay, and I'll explain the reasoning behind crisscross method. Abhi the issue here, this is losing 3 electrons, but this is only has the capacity to gain 2 electrons. The crisscross method is, if this has a charge of -2, so go to the other side and multiply aluminium by 2. What that means is that you have 2 aluminiums now. If you have 2 aluminiums, so total electron lost kitne ho jayenge? They would be 6. Because one of the aluminium would lose 3 electrons, the other aluminium would also lose 3 electrons. So the total electrons lost would be equal to 6 electrons. और इसके ऊपर 3 plus का charge है. Go to the other side and multiply that by 3. इसका मतलब है I have a total of 3 oxygens. That means that if one oxygen gains 2 electrons, 3 oxygens would in total gain 6 electrons. So this is what is happening now. Okay, you're not going to take one aluminium and you're not going to take one oxygen. इसके ऊपर 2 minus का charge था, multiply the other side by 2. That means you have 2 aluminiums in total. And total electrons lost would be 6. इसके ऊपर 3 plus का charge था, multiply that by 3, which means that one oxygen was gaining 2 electrons. Now you have 3 oxygens, so that means the total electrons gained would be 6. अब ये देखो कि the number of electrons lost and the number of electrons that are being gained, I've increased the quantity of aluminium and the quantity of oxygen. But now what's happening is that the number of electrons that are being gained and the number of electrons that are being lost, they have now become equal. Which means that बीच में ना there would be no electrons. जो बीच में पहले फालतू के नहीं पड़े थे, पहले मेरे पास एक aluminium था और एक oxygen था. But now I have 2 aluminiums on one side and I have 3 oxygens on the other side. Is this clear? Zad, is this example clear? Naeem, is this clear? चले ठीक है. अच्छा, we're going to continue with this. ठीक है, in the next class hopefully. अभी हम will discontinue. Do you have any questions about this topic या classes के बारे में पूछ रहे हैं? Anything? Naeem, any questions? Zad? Nee, I was saying, are there any questions that you need to ask right now? I'll just type quickly 1 second. चलिए ठीक है, we'll end the class over here, the demo class. ठीक है. Someone might contact you after this class तो उसके ऊपर हम बात करेंगे. ठीक है, चलिए ठीक है, ओके, टेक केयर, अल्लाह हाफिज.